Okay, so I was going over who I am, so we'll just skip over that. Graeme Rocher, architect at Oracle Labs and creator of Grails and Micronaut. I'm sure you've already seen the slide. I do want to point out, if you pop into our the Oracle booth after this, you can obtain a free Oracle Cloud free tier offer with additional credits and all that kind of stuff. So do join and come along and sign up for Oracle Cloud and etc. So on the agenda today, we're going to do a brief introduction to Micronaut, talk about Java 16 records, how they're used in Micronaut, and we'll do loads of demos, and then we'll have a Q&A session where you'll be able to ask all your questions and so forth. So first of all, brief introduction to Micronaut then. For those of you who haven't heard it, it's a relatively new framework for the Java space that is focused on serverless and microservices primarily, but it's really a multi-purpose framework. You can build CLI apps for it. Using it, you can build message-driven microservices, even JavaFX and Swing apps if you want. It's really a general purpose framework. And it plugs into Java C through annotation processes and completes the framework infrastructure at build time, eliminating reflection and all sorts of things. For microservices, it has an HTTP client server based on Netty. And it's grown very rapidly in popularity and being adopted by significant numbers of organizations around the world. It has a very close relationship with GraalVM. GraalVM is a new virtual machine out of Oracle Labs, which has in JIT mode increases throughput and reduces latency significantly, and also enables you to build compile applications into self-contained native binaries using the native image and substrate VM, which is great for serverless and cloud deployments. And this works really nicely with Micronaut because Micronaut doesn't do any reflection, doesn't do any dynamic class loading. So there's very little to configure, and Micronaut and GraalVM work really nicely together as a pair. So like I said, Micronaut really loves GraalVM, and that you can take a Micronaut application, compute it into a native image, and there's really nothing that you have to configure in the native image build tool for Micronaut, because it eliminates reflection, runtime proxies, bytecode generation, dynamic class loading, etc. And once you have done that, the startup time for Micronaut with GraalVM is remarkable. Dropping orders of magnitude, and memory consumption is significantly smaller, which is really great for things like serverless, CLI apps, low memory footprint microservices, and so on and so forth. Okay, so I want to talk about Java 16 records now. So they were introduced as a preview feature in Java 14, and they address the long-standing need to allow the developers to model essentially data classes or carriers of data that are generally are immutable, and that represent essentially an aggregation of values. Typically this has been done with the Java Bean specification, although that specification was not really designed for this purpose, in terms of implementing things like equals and hash code and so forth. And records solve all this problem by automatically implementing equals and hash code for you, automatically providing accesses, providing immutability, and records, I think, frankly, represent going to be one of the biggest revolutions in Java API design since the introduction of lambdas. I think they have the real potential to change how people think about the way in which Java APIs are designed. So as an illustration of what records do to the Java space, on the left-hand side of the slide, we have a point class, which models an X and Y point. And, as you can see, it implements equals, it implements hash code, and has two values, and so forth. And all of that verbosity is just collapsed dramatically and reduced into a simple declaration in Java 16, which is like record point and the two record components that make up the record. So, it becomes massive reduction in verbosity, automatic generation of equals hash code, automatic immutability, and is going to provide massive improvements to the verbosity of Java code bases. So where can records be used in Micronaut? In a whole bunch of different places. So records can be used to model immutable configuration. You can use them to serialize and deserialize JSON. They can be used to define to model classes that map to and from database result sets and rows. And they can be used as kind of model types when you're validating incoming requests. And in general, I think as well is, with records is they encourage the use of immutability and good application design by default. So rather than the default being mutable and so forth, in terms of the way you design Micronaut applications, you should think in terms of things that being immutable by default, using constructor injection for dependency injection rather than injecting mutable fields. So they encourage a lot of really good best practices in the building of Micronaut applications. So with that, let's actually have some fun and do some demos of using Micronaut and Records, and hopefully you'll get an idea what Micronaut is and what records are. So I have a Micronaut application here, which I created earlier, and it's configured to use Java 16 as a source and target compatibility. And this is a Gradle build, but the same thing would apply to Maven. So in terms of a little bit of an introduction of what Micronaut looks like, you have an application class, which you can use to start your application up and run your application locally, and automatically binds to point 8080, which is probably a pretty familiar pattern for folks who are familiar with Rails or Spring or any of the other kind of Java frameworks out there. And Micronaut comes with a test framework called Micronaut Test. And basically what it does is it lets you dependency inject tests so they can inject components into it, for example, JUnify test like this. So so I can run this test directly from my IDE here. And one of the big differences with Micronaut that you will notice compared to other frameworks and so forth is just how fast things execute in terms of test execution. I actually have an application here that's like spinning up an in-memory database and everything, and it's just really fast to execute. Okay, so now let's build a little demo application of records. So we're going to look at first use case for records, which is configuration. So I'm going to create a new person configuration, and it's going to be a record. So here's my record. And with Micronaut, we have the ability to bind configuration namespaces so this is like the namespace of the configuration, to classes just by annotating them with @configuration properties. And that's really cool because I can use record components to configure essentially how a configuration property is bound, rather than having getters and setters and immutable configuration. We can just use immutability and define record components. So this is essentially what a record looks like, right? You use the record keyword and you define your record components, in this case, name and age. And what we're doing here is we're binding it to this configuration namespace. So what does that mean? What does that give me? Now, suddenly in my Micronaut application, I can come into my application.yaml and I can say person name, Fred, age 30. And then we can come into my my test and we can actually inject that configuration like so. And we can write some assertion here that it works as we expected. So Fred configuration.name, there we go. And if we run that test, it should pass as we expect. So we're binding from our configuration model how my application gets configured automatically using configuration properties. And I think this is a really nice use case for records because it feels really natural rather than having getters and setters and all that verbosity that we had before. And that's really nice. Interestingly, I noticed in a newer version of JUnit 5, you can actually now define JUnit 5 tests as records. So this can actually be simplified even further into a JUnit 5 test that uses constructor injection, and that is actually the same test, but instead I'm injecting my configuration into the constructor of the JUnit 5 test and passing it in, and it works. So I thought that was a nice little addition from the JUnit 5 team to add support for records in terms of writing tests as well, which is pretty cool, and a nice simplification rather than having to use inject and all that business. Okay, so once you have a record, it's pretty easy to dependency inject them into other places. So I can actually, write, for example, a person controller here in my application that exposes the people endpoint, and I can inject that record into my application and into my controller, and then write an endpoint here that just maybe exposes the default person, and maybe we have it just returning a map for the moment, or a string, something like that. And then we can do return configuration.name, and maybe we can say this produces media type text plain, and now we've written a controller that exposes record value, which is pretty simple to do. Now, if I wanted to, now interestingly, as you can see, as I've written this controller, you can immediately note something about this controller in that I'm using final variables to reference my configuration, and I'm using dependency injection via the constructor. So, why am I using a class here then when I can just use a record instead, right? So all of this verbosity can be removed, and I can actually just write this controller like this, which is so much more concise and elegant. And interestingly, look how you can just reference record components directly from their declaration up here inside methods and controllers and so forth, which makes them so much easier to essentially reference rather than having to duplicate a field and all that kind of stuff. It just makes it a whole bunch more elegant, which I think is pretty cool. Okay, so another significant area where records and configuration properties are used is instead of just binding to a single person. It's often the case where in Micronaut you want to have create configuration for multiple people, and you can do that in Micronaut with at each property. So I can say for each property people, I want a new person configuration. And what that does is we can actually alter this definition here, so I can have people and nest them under each one. So I can say Fred, Bob, and I have another person here, like so, and maybe Bob is 25, and then we can define multiple people in my configuration, and I can have them bind to each nested property underneath the people namespace, and that's pretty cool, because now instead of just injecting a single person configuration, I actually can inject a list of person configuration. So now we have multiple, and maybe we can turn all the names of all the people, and we can rename this to the configurations, and we can do a little bit of stream usage, here you can say configurations.stream map person configuration name. It's really nice how you can just reference name with method references. I think that's part of the reason why they chose not to use get name, because it just reads nicer when you reference it like this, and we can collect those up, and we're exposing all the people names. We can come back into my test here and actually write a little test for this, because whilst we're here, we may as well demonstrate building out using Micronaut's HTTP client. So I can say, define a new person client that maps the people endpoint and is going to retrieve a list of string from that endpoint like that. So we're going to, get all the people from there. And, instead of producing text plain, actually, maybe we want to emit some JSON now. And then what we can do is actually inject my client into my JUnit test here, like so, and call client list all the names, get the names of the people, and say something like assert true names contains Fred, like so, and run that again, and you can see that does not in fact pass. Why is that? Multiple possible person configuration, I see. Okay, so there's actually multiple possible candidates. And in my JUnit 5 test here, I'm still injecting a single candidate, so it doesn't know which one is like the one. So I'm getting a non-unique bean exception. So I'm just going to remove that. And we can instead run it again. And this time it fails for a second time. Names is null. Okay, so why is that names null? Let's have a look. My URI is wrong. So I had person.default as my URI, and we can just say that's going to be a get to the root request. And we run that again, and now it's passing. So I've exposed all the people names over a list. I'm making an HTTP call, and it's all working as expected, and we're reading those records. Now, this is just returning a simple list of strings. So one thing that is pretty common for records is to model them as, oops, didn't mean to do that, is to use them to model like JSON responses. So maybe I can create another, person record, which is actually going to model a JSON response. With JSON and Micronaut, what you can do is what you can essentially add introspected to any record. And what that does is it lets Micronaut read and write the record components and instantiate it dynamically and read and write it to and from JSON without using reflection by adding introspected to a record. And that's really, really handy because, in cases where you want to basically instantiate this dynamically and serialize it to and from JSON. And that's what the introspective annotation is. It's a bit equivalent to the java.beans.introspector API that Spring uses and so forth underneath the hood, but instead we made this compile time by adding it to introspected to the person record. Okay, so so now we can like model like JSON responses. And the cool thing is with this approach is you can actually also like model, for example, constraints. So I can say like, the name shouldn't be blank, and maybe the max size of an age should be like 30, and the age should be a positive number, and we don't think we're going to support people that are older than like 120. So you can model these constraints in your application, which is really cool, and have those validated. So for example, I can return that person class from here to like list all the people, for example, and instead map my config to a new person record like so, and maybe do config.name, config.age, something like that. And that will like output my people, but then I can also like add a post request, to add additional people. If I was going to support write operations, which I'm not just yet. But basically what it means is now on my client, I can like actually use this to like as a JSON transport mechanism, right? So instead of like sending a list of strings back and forth, I can say, that assert true new person, Fred. How old was Fred? I can't remember. Fred was 30. And now we're like asserting that Fred comes back correctly in the response, which he does. And that's that's interesting that this contains check passes, right? So this is a demonstration of how records automatically implement equals hash code for you, right? So this check passes because this person record is going to be essentially have automatic equals hash code implementation happening out of the box. So that contains check works already. So let's now make this application like writable and involve some like database access. So what you can do with records in Micronaut is you can actually map them with Micronaut data to JDBC. So I can make this a mapped entity. And the only other addition I need to make is to add a database ID. So I can, for example, make this a generated value that is the database ID and is nullable. And now I have a record that can be read from the database with a generated database ID. Now, the interesting thing about records is they can have additional constructors. So I can add a secondary constructor here that just takes the name and the age, and calls the primary constructor and pass with a null ID, for example, and the other values, right? So I created a secondary constructor so that I can instantiate this easily without an existing ID and save it to the database. So what we can do now is come to my application class, for example, and make this a singleton so it becomes a bean. And then I'm going to add an event listener that listens for the startup event, like so. So when the application starts up. And what I want to do in the startup event is save some records to the database. So how would I do that? So what you can do with Micronaut is essentially create a person repository that saves objects to the database. And I'm going to make this extend CRUD repository, and it's going to take a person and the ID. So now we're using Micronaut data with records, right? So, and in fact, we're going to use Micronaut data JDBC, which allows me to directly work with JDBC to read and write objects to the database. It's not a full object relational mapping tool. It's just a simple data mapper, which works really nicely with records. So I'm going to make this a CRUD repository, which gives me basic CRUD operations. So now I can essentially inject that CRUD person repository into my application class, and we can save some data to the database when the application starts up. So we can say, and maybe we want to base it on the configuration as well. So I can say, give me all the person configurations that are read from the configuration. And these are the configurations that are going to be saved to the database when my application starts up. And what we can do is do something like iterate over each configuration and use my repository to save that into the database, the person into the database, like so, configuration.name, configuration.age, like so. And we can make this transactional so that, to ensure that it's like done within a transaction and roll back if everything goes wrong. I think it will probably be better to use a stream and use save all, which takes an iterable. But just for the demonstration purposes, we can leave it like that for the moment, as I'm running low on time. But essentially, I'm writing some record objects to the database when my application starts up. We can then, instead of using the configurations here, inject my person repository like so, and basically return all the records from the database. And I think we may need to go in here and override the find all method to instead return a list. By default, it returns an iterable. And now it should read those record objects from the database in my person controller instead of just reading them from my configuration. So let's see how this works then. If the demo gods are with me, it should work. So so let's run the test and actually see what happens. And the test fails because my assertion is incorrect. And I think my assertion is incorrect because let's add some like logging here just to see what what's coming back from the HTTP call. So I'm going to enable trace logging for my HTTP client, and you will see when I run this that essentially what comes back from the database is my two records. As you can see, you've got person, name, age, and name, age. And the reason this contains check is failing is because I'm not supplying a database ID, right? So I'll just change this for the moment to be assert not null or assert equals, something like that. Dot size, and maybe like change this to people list, and now the actual test will pass. But yeah, the functionality that I built is essentially working. And it's very easy, like I said, to add post functionalities. So I could add a post method here that saves a new person to the database, and takes my my person record in here, or at least takes a name and age. And we can also add validation rules here if we want as well. And then you can call return repository.save new person and save a record to the database, and it will do the right thing, right? And then it's very easy to do the essentially the same thing in my post request. So I can say person save name and age, and have an HTTP client that basically saves a new record dynamically. So I'm going to say Joe 50 or 40, and actually, sorry, we're going to do Joe 50, and that'll give me a person, Joe, back, and I expect Joe not to be null, and I expect my number of people in the database to be 3, right? So let's see if that works. And it doesn't for some reason. Let me rebuild the project for a moment. That is not working. Okay, so I don't know why that's not working. I've obviously done something. I think I may have a access control issue. Anyway, something is not, I think basically something, this is probably not public. Anyway, I've run out of time, so I'll leave it for the moment and for your imagination, and go on to the summary. So yeah, in summary, Micronaut 2.5 and above already provide like really nice integration with Java 16 records. Records reduce complexity by basically eliminating verbosity and getters and setters and all that business, and lead to a lot more concise code. And records are a great way to model classes that hold data like JSON classes, and reading and writing to the database, and perfect for a lot of use cases in server-side applications. So with that, I have some time for Q&A. Let's see if anybody has any questions. I don't hear you.
Can you hear me now?
Yes, I can hear you now.
Nice. I need to speak heavier. So far, there are no questions, but I will be there soon. That's very lucky for me, so I can ask the first question.
Okay, go ahead.
You are still screen sharing, by the way.
Yeah, I will stop that right now. There you go.
So if I got it correctly, you really built a lot of the Micronaut, and it looks also easy to use, and it's just nice, and the setup that's just perfect. But how do you come up with it? Because you don't just build it overnight and think like, oh, this is the perfect product. How do you get there?
Well, you need a vision for something that's going to be different to what's already out there, right? I think Micronaut is gaining traction and popularity because it really introduced the notion of build time, dependency injection on the server side, and build time AOP, and moving everything to the compiler. Which has makes it it has a kind of that unique selling point of eliminating reflection and building more efficient applications. I think there's so many different ways in the Java world to write HTTP servers, and that's not the interesting part of Micronaut, right? It's not the there's so many ways. There's Vertex, there's Spock, there's Ratpack. There's loads of different libraries for writing HTTP servers, and I think what makes Micronaut interesting and why people have stood up and taken notice, and then you've had copycat technologies like Quarkus and so forth, and movements in areas such as the .NET community to essentially replicate the same kind of behaviors because it's innovative and interesting, right? So that's and yeah, you have to have a unique idea. I think building an HTTP server is not the challenge in 2021.
Nice, thank you. You probably can see it on the right too, but I'll just read it to you. Gijs Lussing is asking a question for you. It's, would you recommend using Spock with Java 16?
I think yes. I still love Spock. I think it's a fantastic testing framework. I used JUnit5 in this demonstration because it's primarily focused on Java. But on a day-to-day basis, I still use Spock every day for my go-to testing framework, and it's just phenomenal as a testing tool. So I would certainly, in fact, like most of the tests that test records support in Micronaut, in fact, are written in Spock. So I don't see why you wouldn't use it with Java 16, and it works fine. Yeah.
Yeah, if you in the audience like to switch, you can switch on the left corner.
How do I stop screen sharing? Oh, there we go. Yeah.
Nice, thanks. So what's up next for you on your personal planning?
Well, we are hard at work on Micronaut 3 right now. And that will be out hopefully in the next few months. And we're moving Micronaut towards more alignment with CDI in terms of how it works, and basically introducing many features and to support that effort. I'm involved in a revision of the CDI specification called CDI Lite. Where we're trying to introduce a build time version of CDI that hopefully will be ratified in the future. And yeah, we're definitely working towards making Micronaut in general more standards compliant and so forth. And that's something that is on the agenda. But we have to balance that out with our underlying philosophy, which is never to use reflection, and many of the specifications depend on reflection and so forth. So we have to strike that balance, and we'll continue to do so.
Nice, sounds exciting. Yeah. In the meantime, we have more questions again. There's Bert Scholter, and I'll also just read that out loud. If I understand correctly, you automatically get getters and setters for properties. When defining a service as a record with configuration as a property exposes that configuration, which might not be intended.
So you don't get setters. Records are immutable by default. You get getters, right? And that's And that's by design. That records are designed to be holders of data, and for that data to be exposed and to be part of a public contract.
So it's only getters, the hash code, and the equals.
Yeah. So if you are concerned about exposing properties, I think there's ways in which you could have certain methods within records be private or so forth. Otherwise, there are other ways to do immutable configuration, like in Micronaut, which is you can just use an interface, right? So that's another way to do it.
Okay, nice, thanks. Maybe for the last question for now is brief. I hope I can pronounce it. Shivan Garg. Could you please tell in brief the use of introspective annotation?
Sure. So I think it might actually be better to share my screen and like demo it more.
Sure.
Probably makes more sense because it'll help me like explain it. Basically, when you add introspective, what it allows you to do is what allows Micronaut to do is essentially you can obtain bean introspections. So I can say person.getClass and get an introspection like so. And the introspection will allow me to iterate over and obtain knowledge about the properties of a class. So if I iterate over this, for example, and then output property.getName, and I run this in my IDE, you will see I've now messed up something. I'm going to roll back. Sorry, I'm going to roll this back for a moment. Just see whether I can. Okay, so there you go. As you can see, using the introspection, I've been able to figure out which properties this class has. And for that, what it means is you can essentially write logic that is able to introspect and understand the names and types a property has, which is necessary for doing things like serializing JSON, right? Or serializing XML, or reading and writing to a database. I can also do things like, do introspection take this introspection and instantiate a new object, so with like Fred 30, like so, and get a new instance and basically dynamically instantiate an instance of Fred. Without, I think probably I would need to put in null for the ID. There we go. Dynamically instantiate an instance of Fred without without relying on reflection or dynamic behavior. I can also do things like obtain from an introspection a particular property, for example, the name property, which I believe is a string, and then use that property to read dynamically from Fred the value of what is the name of Fred, right? So it allows me to essentially introspect person and figure out its properties, instantiate it dynamically, read the properties dynamically, and all of those are requirements for a framework to work if it wants to dynamically produce JSON or dynamically deserialize from JSON or dynamically read or write to a database and so on and so forth. So I hope that helps.
Cool, thanks. Thanks very much for the elaboration. I think we're out of time, so I want to thank you very much, and okay. I hope you stick around a bit. Have fun at the rest of the conference, and thanks for being here.
Thank you. Thanks a lot. Bye.